So it affects 10 million Americans, mainly in the northeast and northwestern regions, so like Seattle and New England, that area, and especially like Minnesota. And it occurs 40% of the year, and 4 out of 5 people with seasonal depression are women, actually, just because of genetics. And the main symptoms are oversleeping or insomnia, overeating, and weight gain, because since it's in your hormone center of your brain, it negatively affects all of your biological clocks.
So for our sources, for our research, we have various universities and organizations that deal with SAD. And our stakeholders would be people that have SAD in the northern regions of the US. It's colder up there, the weather's not as sunny, so that's where most of our stakeholders are located.
So when looking into the existing solutions, we just picked some of the most interesting ones. So the one on the top left is a hat that has a sun lamp attached to it. And the problem with this one is it's really expensive. It's about over $200. And also it's really inconvenient because it's not very energy efficient, and it also just looks kind of funny. And then the top right is just your traditional sun lamp. It's also about $200. It only helps about a third of people with mild seasonal depression, and it helps even less people with severe seasonal depression. The one on the bottom right is a patent. It doesn't have a lot of research behind it right now, but the idea is getting Botox so you can't frown, and that would make you not depressed. But like I said, there's not enough research behind that right now. And then the one on the bottom right is the best solution we found so far. It's about $50. But like I said before, sun lamps aren't very energy efficient, and also it doesn't always help people that have some.
For our design criteria, we went with effectiveness, cost, convenience, mobility, and energy efficiency. For energy efficiency, we wanted to focus on LED bulbs because they're known to be more energy efficient, and they may be more expensive, but they are the best to use. For mobility, we wanted it to be easily accessible to everyone. We want to implement it in office buildings and classrooms because it also affects a lot of college students. For convenience, we wanted it to be easily accessible, same as mobility. And for cost, we were shooting around.
I think it was about below $100 for sure, because some of the solutions that are out now are a lot pricier, so we'll bring the price down.
And lastly, for effectiveness, we wanted everyone to feel a mood change when using the light bulbs. So our group assembled around October, and we all went around the classroom and wrote our problem on a whiteboard, and everyone in the classroom contributed by writing solutions that they felt like would help solve our problem. And as you can see, the board got pretty filled up.
So we took the existing solutions that we researched and some of the ideas that we came up with and put them in the solution matrix, which is just weighing each of the options based on the criteria we talked about. And we did 0 to 5, where 0 was the worst, and the best solution that we had was smart bulbs, which we'll talk about.
Okay, so ideally how we wanted our prototype to work was first you start with the weather. The weather is whatever it is, like, cloudy outside, and then the Pi would get that information from a local weather station and send it to the bulb, send that information to the bulb and change the color. So that's basically how we had it.
And for those that don't know, a Raspberry Pi is like a mini computer that you can use to program or code basically anything that has an API, or you can.
And so to justify the solution, we looked into more research. Cambridge University and then a university in Australia both confirmed that using lighting changes help people with seasonal depression, especially when the light is a certain wavelength, and that wavelength is the blue-green color. So that is the color that the lights would turn to when the weather is not ideal.
So for business and fundraising, how we fundraise our money, we use GoFundMe, and we got around $300 for it. That was our goal, was for $300, and we got $300 for it. Competitors would be General Electric Sea Life bulb collection. They changed colors too, but not based on the weather or anything. They're just competitors because they kind of do some similar stuff. And also Philips Smart Bulb too. They got the same stuff. Our price range would be under 200. I said 100, but the other bulbs were very expensive, and other solutions were expensive, so we just had to keep it under. Our target market would be universities and office buildings, because a lot of college students have SAD too. So yeah.
So to start building our prototype, we got the supplies, which is the Raspberry Pi, like Joanna talked about, and a couple other things to set up the Raspberry Pi. And then we also found an API weather database so that we could access the weather. And we were using Python, the coding language, and then the lights we had were the Magic Q lights that change color and brightness. So we started by setting up our Raspberry Pi, and we connected the weather database to the code for the city Melrose in Massachusetts, which experienced SAD. And then we bought new light bulbs, because the ones that we started with didn't actually change color, which was a big part of our design. And then we can manually connect the Bluetooth lights to the code, but what we had problems with is having the bulbs and the code automatically connect, and also we had trouble finding the commands that would change the color and brightness of the light bulb.
Right here you can see some of our coding. On the top right side you can see the Bluetooth address for one of the light bulbs we use. We had to manually look it up on the Raspberry Pi, and then on the bottom left side you can see we searched up the weather in Melrose, Massachusetts, since it's in the northeastern part, which is where we wanted to focus our problem on. And I know it's a little small, but at the bottom you can see the weather, the air pressure, basically a lot of details behind the weather.
So we reached out to a lot of experts to help us with this, because all three of us don't really have any computer science background. So the main person that is helping us, or that we got information from, was Yuri Shaki. When we were researching, we found his website where he reverse engineers a lot of light bulbs. He actually lives in Israel, which is pretty cool, so we Skyped him, and he gave us a lot of information about connecting the bulbs to the code. We also talked to the computer science teacher at our school. He was very helpful as well. And then Siddhartha, which is a student at UTD Computer Science, who gave us the idea to use the Raspberry Pi, because we are also looking into source code for the code.
We've made a few changes to our prototype within the process. Starting off with the bulbs, we changed to 3 different bulbs. Our first bulb, it didn't work. It was the Sea Life. We used the General Electric Sea Life bulb. That one didn't work because they only had one color, and we found that out late. So we switched off to the Magic Q light bulb, which is that one. It's on the screen right there. That one changes colors, but it doesn't have like, there's no way to like get into it and crack the code to, there's no API to control it. And so our last bulb that we settled with was the Philips Hue. That one has an open source code so we can get into it and control it. The second part of our changes was the code. We were going to do Amazon Alexa source code and just like put it in a Raspberry Pi and hope it works, but as she said, Siddhartha recommended the Raspberry Pi to us to use.
So in every project there's always challenges, and one of our biggest challenges was Jim. Jim is the name of our Raspberry Pi. Died halfway while we were coding. We had managed to successfully connect it to a bulb, and just when that happened, she fell off the table and she died. And we had to quickly order her, and she came in like a few days later thanks to Amazon Prime.
The final product that we have, like we said before, can connect to the weather, and it correctly tells us the weather for Melrose 100% of the time. But we can manually connect the light bulbs, like I said, but we can't do it automatically, which is kind of an important part because we wanted this system to be really hands-off. And also, like I said, the code and the lights aren't connected right now because we didn't have the API or the commands to do that. So for effectiveness, it was a partial success because the code that we have works and the research that we found backs up that this would work, but like I said, it's not finished. Cost was a fail because each of the bulbs were over $15, some of them $20 or $25, which was too expensive. Convenience was also a fail because it doesn't work, and that's really inconvenient. Mobility would have been a pass because if this was installed in colleges and offices, you're there most of your day and most of the week, so that would have been really helpful. And then energy efficiency was a pass compared to other solutions because the LED bulbs are a lot more efficient than existing sunroofs.
In conclusion, we did not end up finishing our prototype due to our lack of computer skills and programming skills, and we believe there's no further research needed to continue the project. We would just like to have someone that has extensive programming skills to continue on the project, and we believe it would be successful.
Any questions?
Okay. Some things that I would have liked to have heard is how you measured mood when you define your criteria up front. I know that that was one of the most important things, right? That's the whole reason behind it. No clue how you measure that though. And also, like, what were your thresholds on the weather? Like, what do you believe, based on research, constitutes a change in light? Just running through two more comments. Love the brochure, appreciate that. Something very easy to do, and your audience greatly appreciates it. So good job on creating that. And then the last comment is, I liked how you didn't shy away from the word fail, because failing is part of the design process. Now, I wouldn't have highlighted in red, I would have done orange or something, because it's not necessarily an end, but I do think that when we talk about the engineering principles, if you would have pushed through some of that, maybe you could have worked through some of the problems you were having with defining the full solution in the end. But still, appreciate that you didn't shy away from the word, because it's not as scary as what people make it sound like.
Thank you.
Okay, next we have North Dallas with, I don't know, which project will this be, North Dallas? Clicks?
Hello. Good afternoon, everybody. Good morning. My name is Amara.
My name is Tina.
My name is Carlos.
And for our idea was called interchangeable cleats. How many of y'all play baseball or softball in here? 1, 2, 3 of y'all? All right. Dang, that's right. Softball, okay. How much money do y'all